Again, a set of ordered pairs or a set of corresponding points represents a relation. So I have two sets of relations here. And I want to determine is a relation a function? If we remember, a function only exists when every first element corresponds to exactly one element or a unique element. That's a better way to say that. So let's check those out. In the first set, let's just list all the unique domain elements. So I have a 1, a 2, a 3, and a 4. Its range, it consists of all the second set of those elements. Its corresponding pair. And I have a 5, 7, and an 8. If it's a function, every element in my domain will correspond exactly to a unique element or to one element in its seconds. So 1 corresponds to a 5. Every time I have a 2, it corresponds to a 5. A 3 corresponds to a 7, and a 4 corresponds to an 8. That is a function, because every time I start with a 1, I get a 5. Every time I start with a 2, I get a 5. That's all right. I just want to make sure every time I start with a 2, I always get to the same ending. Every time I start with a 3, I get a 7. Every time I start with a 4, I get an 8. So this first set is indeed a function. Let's look at the second set. And I'm going to again just list them out. All the elements in my domain. I have a 5, a 7, and an 8. That's the entire listing of my domain. My range elements are a 1, 2, 3, and a 4. So let's look at the first pair. I start with a 5, I end with a 1. So good so far. Second one, I start with a 5, I end with a 2. Yikes. Don't know what's happening. I want to make sure that every time I start with a number, I know what it's going to end with. But when I start with a 5, it ends with a 1 or it can end with a 2. And because of that, this relationship, it's a relation, but it's not a function. On the other hand, this one is a function. And I hope you're able to see the distinction between those two ideas.